So this is a very unique space to give a tech talk. I definitely didn't expect this as I was going in. When we were making the slides, I told the design team that I thought the minimum font size was too small. And they're like, you know what, Chad, don't worry about it. The image is going to be big enough. If you really like the talk, you can stick around. Avengers is on at 7, and then at 9 o'clock, it's the Incredible Hulk. My name is Chad Jennings. Thank you for joining us. Make yourself comfortable. This is the plushest set of seats I've ever seen for a tech talk. For the next 47 minutes, we're going to be talking about HSBC's migration journey into BigQuery. There's no laser pointer, is there? All right, so I'll just gesture to elements on the slide, and hopefully that will work out. You can see from the list of speakers that we've got quite a crew up here. And the reason we need this many people to tell this story is that it's actually quite a significant story, right? When the world's largest financial institution migrates from on-prem into the cloud, they're going to have some very specific requirements and very specific regulations to which they need to adhere, and that's going to require them to do some really innovative things. And the HSBC team has really risen to the challenge, and they've invented some new technology, and we're going to describe that and describe their journey to the cloud. So if there are folks here who are interested in data warehouse migrations, I think you'll find this material very interesting. So the cast of characters are the following. So my name is Chad. I am a product manager for BigQuery. And then Jan is a colleague of mine from the professional services organization, and he has been moving along with Srini and Santa in lockstep for about the last year to make this migration happen. So the quartet of us, not the Beatles, this quartet, are going to take you through the story. So here's how we're going to roll it out. Do a little bit of an introduction and some announcements. We've got some new stuff coming out. It was mentioned in the keynotes, but we'll go into those in a little bit more detail in this session. And then Srini is going to come up and talk about the migration principle, scope, and strategy that HSBC developed to guide the execution, which is what Jan and Santa will talk about. And then we'll kind of end it with, oh my goodness, why would you do this thing? Like, what are the benefits that you get out of it? Because it's not a minuscule amount of work. All right, so intros and announcements. First, we are aware that there are folks who will be joining on YouTube, so maybe they haven't all, folks watching the video may not have all seen BigQuery. So if you know what BigQuery is, there are 2 slides of introduction. So pull out your cell phone, just put it on mute, but watch a YouTube video really, really quiet or check your email, but in 2 minutes I'll call you back. If you don't know what BigQuery is, then for the next 2 minutes, you are my people. BigQuery is Google Cloud's enterprise data warehouse for analytics. The core things you need to know about it is it goes super fast over super big sets of data, and it also goes super fast over small sets of data. And you really don't need to worry about whether your data is big or small. We'll handle that part of it for you. You use SQL to interact with it. Actually, I have to update the slide because after the keynote yesterday, you use SQL and connected sheets to interact with BigQuery. So SQL speakers and spreadsheet speakers can now interact with BigQuery directly. And most important on this slide is that it's fully managed and serverless. And what does that mean? All right, so in the huge donut on the left, you'll see a whole bunch of tasks in gray. And these are tasks that system administrators or database administrators need to conduct to keep their data warehouse fully fed, watered, content, happy, and performing. So from performance tuning to patch upgrades, reliability monitoring, et cetera, that is all stuff that Google handles for you if you're a BigQuery customer, or any of our fully managed services. We take care of that for you, leaving you to worry about your business, right? What analysis do you want to do? What insights do you want to try to pull out of your data? We'll handle the rest. All right. That was 1 minute and 42 seconds, and I know because I'm watching on the clock. So if you've been off checking your email, come on back now because this next set is for you. So Google Cloud, it's part of the information superhighway, and a fair and reasonable criticism that Google has had to withstand is, hey, your services are fantastic. It's, that's the information superhighway, but would you please pave the on-ramps? And so that's what we're discussing here today with the announcement of the Data Warehouse Migration Service. So this is an agent or a tool that you can use to automatically move data and schema from on-prem to BigQuery and not have to manage that process or not have to manage the details of that transformation in the schema migration by hand. The way it works is at the top left box here is the source, right, the on-prem system. You actually download an agent onto a VM in your source system that then configures the migration. It looks into your tables, the metadata in your tables, and figures out what the relationships are, and then posts that back to GCP and says, okay, I understand what the schema should be inside of BigQuery, let's move it. And then it transfers the data over into BigQuery using the BigQuery data transfer service, and then loads that straight into BigQuery as the same schema, and it transforms data types, et cetera, as the same schema that you started with in Teradata. So we are very excited about this tool. We want our partners to use it. We want our customers to use it to make it a lot easier to get their data from the on-prem system to the new one. Of note, we should say that the supported sources right now are Teradata, Redshift, and S3, and we're going to be expanding this list as the beta continues. We also have some announcements around individual features. So these were contained in the keynote, but let's just spend a moment on them here. They're relevant for data warehouse migrations because if you move, say, Teradata to BigQuery, but BigQuery doesn't have all the features that you're accustomed to in Teradata, that it won't be the same rich experience as you're accustomed to, like with the brakes taken off. So we are very aware that we need to make sure that you have things like integer range partitioning, scripts and stored procedures. Those are all in alpha right now. The BigQuery storage API is another very significant launch. That's gone to beta, and that actually allows either you or any analysis tool to get direct access to BigQuery storage in an exceedingly performant way. In an unlimited way as well. Right now, export jobs are limited to 10 terabytes per day. With the storage API, you can extract as much data as you need. So this speeds up things like visualization tools or data flow and data proc jobs that are running on data stored in BigQuery. The goal of that API actually is to make it so that BigQuery is the place to store all your structured data because you can get to it with any analysis tool you want to once it's inside of BigQuery. And then launching to general availability, clustering is going GA, went GA yesterday, BigQuery GIS, and the merge statement. So you can see by our efforts here that we are continually improving BigQuery so that when you migrate your data from one to the next, that you have all the features and all of the speed and velocity that you need in the cloud. One of the things that I think the BigQuery team does particularly well, and yes, I'm biased, but I'm going to say it anyway, is that we try to engage very, very deeply with our customers. At scale, we have a public issue tracker, and we track issues that the public reports to us. And so upvotes in the public issue tracker does move things up in our roadmap. So I encourage you all to use that and upvote the features that you want us to make next. For Platinum customers like HSBC, we actually get into the weeds and design our betas and GA requirements for the requirements that our customers have. I won't read through all of these features that HSBC is using inside of BigQuery, but I'll point to the one on the bottom right. So customer-managed encryption keys. We actually designed the general availability launch requirements to match what HSBC needed so that we could get to GA faster for the use case that we needed to support, which was to please this very important customer. Any case, so with that, I'm going to kind of tie the bow on the intro and announcements, and talking about the features that HSBC is using is the perfect segue over to Srini from HSBC.
Hello, everyone. Good afternoon. This looks like a movie star for me. I just wanted to be a speaker, and Google made me a movie star here. So very well, okay. So my name is Srinivas Vaddadi, and I'm a delivery manager at HSBC. So I lead the data on cloud program, and my team supports the cloud migration initiatives. So coming to I just want to start with a quick intro on HSBC. I think many of you already know HSBC, but just to give you some numbers here. We have around 39 million customers, spread across 66 countries. So coming to the data assets part, we have been growing rapidly. And as of 2018, we have around 169 petabytes of data. Compared to 2014, we had 56 petabytes, which is 300% increase. And we have data centers in 21 countries and more than 94,000 plus servers, and some other statistics on the slide there. So going to the cloud journey, so HSBC has started the cloud journey with Google about 2.5 to 3 years back. In 2017, we started our development environments, and we started working on the different requirements, understanding Google capabilities, and mapping them to our needs. And by end of 2017, we had a contract with Google, and Google was selected as our strategic partner for data and analytics services. Going ahead in 2018, we started building our Google Cloud Foundation platform. And HSBC being a very highly regulated industry, we need to make sure that we adhere to all the regulatory policies and also make sure that our data is secure, at rest, in motion, and also we have the complete control of data. So in this regard, we worked with Google, collaborated with them, co-developed with them, and as Chad said, some of the features you have seen in the previous slide were implemented for us to make sure that our data is secure and we don't have any data leakages or data exfiltrations. So those services are the customer-managed encryption key, the VPC service controls, and the access transparency logs. These were really helping us to make sure that we have complete security and we don't have any data leakage or data exfiltration. And it also helped us to get the approvals to move sensitive data to Google Cloud. In parallel, in 2018, we started analyzing our data warehouses to see which of them can move to cloud. And in this slide, you can see this is one of our critical data analytic workload, which we are currently migrating to cloud. As you can see, we being a big international company, we have this data warehouse present in more than one country, at least 10 countries here. So our approach is that we started with UK, and that is the most complex data warehouse. And we have created a template for that, and we'll use this template for migration of other countries, wherever the regulators allow us, and Google Cloud is present there. So what are the primary challenges we are trying to address here? So as many other large organizations, HSBC has a rapid and tremendous growth of data. And one of the constraints we're seeing is capacity. On-prem, we are not able to, either we have to increase our infrastructure to meet all the data coming in and to meet our analytical needs, or we need to look at other options. And that's, of course, that's the cloud. Secondly, now business is really constrained because I talked about 169 petabyte of data. But what is the use of data if you're not able to get the business, the valuable insights they want? So because of capacity and processing constraints, we are unable to really service our customers as we want to. And other challenge is that these warehouses have been built over 15 years of time, and we have challenges with the metadata, with data lineage, and that are causing a duplication of data as well as data quality issues. So to address this particular thing, particular challenges, we started our journey to cloud. So the first use case I've taken is a UK data analytic workload. So here you can see the, when I say data warehouse, it's just not a simple data warehouse, but it's a combination of, it's an ecosystem of, the ETL jobs, reporting jobs, and scheduling jobs, and analytical users using this data for multiple purposes, right? It's not a simple thing. Just to give some numbers to you here, this particular UK data analytic workload has more than 6,500 ETL jobs and more than 2,500 reports. It gets data from about 100 sources. It has 180 terabytes of data and a rich history of 30 years with millions of customers and transactions. And also, it supports regulatory reporting, like liquidity reporting and FATCA reporting. So this is a huge and a very complex, critical data warehouse for HSBC. And when we embark this journey of moving this to cloud, we seek the help of Google. So Google partnered with us to evaluate multiple options. So evaluated options like reengineering, lift and shift, and finally we zeroed in on what we call it as move and improve. So what do we mean by move and improve? So we want to move our data warehouse to BigQuery, get all the capabilities and all the all the capacity and all the elasticity, etc. of BigQuery, and that helps us to solve our capacity constraints. That's where we are trying to solve immediately, because that's where we need to either invest more in on-prem or go to Google Cloud. And to improve on that, we have to improve our challenges. So I talked about some of the challenges like metadata and data lineage. So now we are taking this as our next task and adding metadata, data lineage, etc. to our warehouse on Google, that's a BigQuery, and making it more simple. As far as the ETL jobs are concerned and reporting jobs are concerned, we talked about the numbers there, the staggering numbers of 6,500 plus and so on. So we took a conscious decision that the primary concern or challenge we're trying to solve is capacity. So we'll go ahead with a infrastructure as service option for our ETL jobs and reporting jobs, and take our ETL and reporting as is to Google. And also, as we are taking this journey, we looked at how can we simplify this particular complete migration. So what we did is, because this data warehouse was built over the last 15 years, believe it or not, we don't have a good inventory of it. So we started looking at what applications, what reports exist on this data warehouse, and how we can actually look at which of them are used and unused, right? So we worked with the stakeholders and identified about 600 plus reports are not being used at all. So we immediately said this can be demised. Similarly, we're working with stakeholders and business stakeholders to understand which of the applications are not used and which can be not migrated, and looked at demising of those. So in that way, we are only migrating the applications and reports which we want to migrate. And in this journey, we're also looking at simplifying our ETL jobs and taking off the technical debt of previous migrations so that our production support can have a better sleep at night. Coming to the core data first. So we took the approach of moving the core data, core tables first. This gives us the data foundation, because once we move our core data and tables on Google, we give opportunity for the next the new use cases coming in to use this data and develop in Google native. And also we are looking at agile and fail fast. So we are in this transformation journey. HSBC has been in transformation journey of agile and DevOps for some time now, and this project is completely agile and DevOps. So we have always looked at how we can deliver smaller workloads and not a bigger ones, and how we can actually use a fail fast so that we can actually build some patterns and proof of concepts and achieve the target what we want. And one important thing I want to talk about is innovation and automation. From day one of our journey, we took this very seriously. We wanted to make sure we automate everything. Automate everything possible. This is very much required because we are looking at a massive migration here. And if you go with a manual effort, we'll not be able to meet our timelines. And as any other project, we have strict timelines to meet, because otherwise we have to buy new infrastructure or renew new licenses, which you don't want to do. So with this, mantra of automation, we went ahead and created multiple accelerators. And some of these accelerators are the data reconciliation tool, which reconciles between the source and the target using hash algorithm at record level, and make sure that the payload is delivered from source to target without any loss. And if there is a discrepancy, we can actually look at reporting, and production support can fix that. We have one more accelerator called the SQL Parser. So many of you know that when we look at a native data warehouse, we have native SQLs. And they are not one or two, but there are thousands of them. In our case, there were 3,500 SQLs. So we don't want to migrate them one by one. So we did a automatic parser, which migrates the SQLs of native into a BigQuery compatible SQLs. Third one is data lineage tool. This is a very critical tool for us, because as many of you know, these warehouses have been developed for the last 15 years. So there is no data lineage, there is no documentation. So this tool helps us to have a lineage between the reporting to the data warehouse to the source. So it helps us to prioritize our workloads. As we are running our sprints, we want to migrate, say, X number of reports. We know which data, which tables have to be migrated before we can go to the reports. And this is also useful for our stakeholder management. And as I told you, the Google partnership has been a great help for us in this. So as we did the decision of moving our ETL jobs and reporting as a infrastructure as service to Google, I think this is the first time anyone is doing that in the entire world. So we faced challenges, technical challenges, which we had to resolve. And that's where we reached out to Google. And Google partnered with us in not only helping us to understand the challenges, but also helping us to do proof of concepts and building patterns. And these patterns are very useful for us because these helped us to really put a factory migration in place and not really a one by one, but we have a factory running now. We actually migrate the ETLs by bunches and by chunks, depending on our workload of migration. So at this point of time, I would like to invite Ian Peuker, who is our Google PSO lead and who has been with us for the last 1 year, helping us now accelerators in this automation. And my colleague, Santa Karmakar, who is my senior lead technical architect at HSBC, to take us a little deeper into this accelerators and technical challenges. Santa and Ian.
Thank you very much, Srini. Even though I've heard those numbers many, many times, it's still impressive, especially on such a big screen. So, hi everyone. My name's Jan. I'm a strategic cloud engineer in the professional services organization of Google in Singapore. Professional services helps our customers with the biggest and most complicated technical problems, usually through consulting and engineering, and very often together with partners. So before I go into the details, let me quickly explain how those kind of data warehouse migrations typically work. So there's two kind of types of customers. There's the ones who just want zero impact on their operations, and they ideally want some automated tool and just want to have that done for them, even if it's in an opinionated way. That's, for instance, what Chad introduced with the BigQuery data migration services. That's great. And then there's the other type of customers who want to leverage as much as possible in the cloud, even if it means re-engineering. And that's what Srini called the cloud native approach. Now, as we heard, HSBC is right in the middle, and that's why they engage professional services. Because in a move and improve approach, we need to break that down a little bit more. So in order to visualize that a little bit, I'm going to show you a classic reference architecture very briefly for data warehouses. So those three boxes are always great. Boxes mean architecture diagram. On the left, we have, for instance, an ingestion layer. In the middle, you have processing and staging. And on the right, you have your reporting and analytics normally. So if we would go in a standard project, we would typically suggest one of our reference architectures, like a reference architecture for ETL, which look like this. You have your batch files on cloud storage, you get some events and streaming through PubSub, you process that in Cloud Data Flow for your ETL, but maybe you're not completely event-based, so you still need some scheduling and some dependency management in place. Maybe you even do ELT inside, so you use Cloud Composer for that, and all of that goes into our petabyte scale serverless data warehouse, BigQuery. Now, as Srini said before, we couldn't just use that, and Santa is going to walk us a little bit through the details of HSBC's more complicated architecture and what exactly we did to resolve.
Thank you, Jan. Hello, everyone. My name is Shantadas Karmakar. I'm a senior lead architect in HSBC India. I'm really privileged and honored to share a few of my experience in this journey with you all today. The current platform is pretty complex. It has numerous types of feed to be processed. N number of tools are in use, and many different complex interfaces with various trusted source systems. As Jan said, it has 3 layers: ingestion layer, processing layer, and reporting layer. Once the various feed from the trusted source systems arrive at the staging areas, the scheduler at work invokes a shell script job. It first inserts a record into a job control list table. This table has a lot of inserts and update operations. After that, ETL tool performs a lot of complex transformations following business rules. Few such transformations, like deduplication of records, then historical data processing based on slowly changing dimension, snapshot load, key generations, key lookup, etc. At the end of the processing, it generates a load-ready file. This file gets inserted into warehouse system via various DB utilities. We first create the core warehouse table, which comprises the 360-degree view of the customer. After that, various aggregation tables forms the semantic layer. Since the current architecture is pretty complex, we could not use the reference architecture as is.
Exactly. Thank you, Santa. So if you have such a complicated system, what you need to do is break down your work. Now, again, there's two options to break down your work. The classical enterprise architecture approaches would be either to go system by system or data by data. System by system, meaning you go through all of your dependent systems and you just check which ones have to be migrated, and you make a list of all of your dependent applications and of your sources. And the data-driven approach is a little bit more, you go into the schemas themselves and then you find out which schemas are used and then you migrate data by data incrementally. Now, in this particular project, as Srini said before, we decided actually against those two approaches because we wanted to have a real business priority and a business impact. So rather, we decided to go with architecture decision records, and those would be based on technical user journeys. So in order to develop those technical user journeys, we basically did an agile board. I guess all of you have seen this. This basically looks like a Scrum board. You can imagine those to be user stories. So I'm going to give you a few examples of those user stories. Ours that we used were much, much further broken down, but for the ones who know data warehouses, some of those words might already make sense to you. We have mentioned, for instance, change data capture for like event handling. We had slowly changing dimensions, what's sometimes also called data load, delta load, or incremental load. Those are the typical data warehouse topics that you just need to address if you go through such a migration. But we had some other topics which were more specific to the financial services industry. Santa briefly spoke about deduplication to make sure that the data warehouse has a very, very consistent golden source of data at a specific point in time that you need to maintain. But our impact framework didn't only base on the migration impact. For instance, we also looked at the business impact. We prioritized the archival data and historic data because that allowed us to move already things into the cloud and therefore take load of the old system, making the old system faster for the users as well as the new system. Another impact was a cultural and organizational impact. Something as trivial as SQL status codes can be very important for your production support teams. So we made sure that everyone knows them, that we get the right metrics, the right observability very early on in the process to also start to explain people that they don't have to manage hardware anymore, but now have to manage queries and slots and performance and quotas and look at very different metrics. And that's a change that takes humans a longer time. So we wanted to get that started very early in the process. So once we had those technical user journeys defined, we broke them further down into POCs and developed different options for those POCs. In those POCs, we looked again at the principles that Srini mentioned before, but now broke them down a little bit further into technical principles, and Santa is going to talk about them again.
Once the various patterns are identified, we established few key design principles which we followed throughout the execution of the project. The current platform is aging and it has a lot of disruption. With the use of various PaaS services such as Google Cloud Storage for staging area and BigQuery for warehouse, we wanted to improve the performance of the system. We want to maintain only single copy of the data. By restricting multiple copies, we improve the maintenance overhead and also we reduce the cost. The data is always secured with customer managed encryption keys, and we also applied VPC service control to prevent the data exfiltrations. Our consumption layer and processing layer are separated out. We have used multiple authorized views to give access to the data to various reporting layers and analytical users. With this, let me take you to our data migration strategy or steps. It has 3 steps. Number 1, migrate the as-is schema onto BigQuery. and repoint all the analytical and reporting load onto BigQuery. Step number 2, migrate all our historical data onto BigQuery. Part of the second step is set up a change data process so that the warehouse system and BigQuery always remain in sync. Set up a data reconciliation tool and use metadata tagging as where possible and applicable. Third step, migrate the data access layer by converting all the SQL script into BigQuery compliant scripts. This seems to be a very, very long and time-consuming task. To speed up the development and reduce the human error, we introduce a lot of accelerators. Here we are going to talk about 4 accelerators today. The first 2 accelerators, Schema Parser and Data Reconciliation Tool, helps us migrating our data layer onto BigQuery. SQL Parser helps us migrating the data access layer onto GCP platform. And Data Lineage Tool provides the dependency across various components in the pipeline. With that, let's look into these tools. I will combine the Schema Parser and Data Reconciliation Tool in my next slide, and here it is. From the source system, we first extract all the table definition information and create a Avro schema parse file. And then we fetch all the records from a specific table. And we convert them into Avro format, load it into a data file. While doing so, we also apply hashing operations and create a hash data, load that data into a different file along with all the key elements in it. We call this as a passport file. Once the hash file in the passport file, the hash information and the data files are created, we load this into GCS using gsutil. From there, we execute bqload command to load the data into BigQuery. If the tables are not created, first we create the table, then the data gets loaded there. Once the data is loaded into BigQuery, we again apply the same hashing operation, but this time we do it on BigQuery and get the hash value. And then we compare the hash value with the data what we have received using the passport file. Whatever differences, discrepancies are there, it gets reported into our reporting layer. And our production support team finds it quite useful to correct this data. This tool is quite helpful and very quick. With the help of this tool, we could reconcile data for a specific table in a couple of minutes, which generally takes almost an hour if I want to do it manually. It has consistent and repeatable process, which eliminates a lot of human errors. Audit is enabled in every operation in this tool. Moving the historical data onto BigQuery is quite easy task. But when we are moving the change data on an everyday basis to sync my on-prem data warehouse with BigQuery, we need to set up a change SCD type 2 operations. So that was a little tricky for us. When we are migrating a small table, it's just one-step process. But if it is a big table, we need to migrate the data chunk by chunk. So once we have migrated the data layer successfully, then we look at how can we migrate the data access layer. What would be the strategy? How can I bring a lot of parallelism? That is what cloud is known for. For that, Jan is going to talk about it.
Thanks a lot, Shanta. So as Shanta just said, we couldn't just take the easiest approach. So once we had our technical user journeys and we had broken down the decisions, we could have just done different POCs and decided for whatever is the easiest. But the goal was, Srini's goal really, was still to move and improve. So we still wanted to get a faster time to insight. We wanted to get higher availability and higher performance. So we couldn't just accept tech debt. And to illustrate that, I'm quickly going to show an example based on surrogate key generation. So in your regular relational database or data warehouse, you generate surrogate keys typically using a sequence or some kind of row identity. Now, we could have also still generated a sequence, but ordering stuff manually, monotonically increasing, is always a bottleneck. There are some academic solutions around that, but the fact is, if you do that somewhere, it's going to make stuff slower. Now, BigQuery is fast because we parallelize. So we wanted to find a solution that we can parallelize while still maintaining full consistency of our batch loads and make sure that reconciliation is successful. So how do we do this? We did this using UUIDs. Now, I used the word hash here because we're actually not using the UUID function in BigQuery. We're actually hashing multiple columns that we define as key columns. The trick here is, there's actually two tricks. One is we're using the information schema in BigQuery to find those key columns and to find the schema itself. We worked very early in the alpha and beta programs together to use the information schema functionality. And the second trick was to use a merge statement. Now you would wonder, we're just inserting, why do you want to merge? Ignoring now the history processing itself, but if I just insert new values, why do I need a merge? The trick here is the merge has an update if it matches. In that update, I can throw an error. And now I know exactly which roles don't match. So I don't actually execute the merge, but I throw an error, and that gives me exactly the information which rows and columns are matched and which are a problem in the actual process. Now, once we had that solution and working very fine, we actually found that we could also solve another problem. In some data warehouses, you have a feature that's called unique set tables. It's a rather obscure feature, in my opinion, that allows you to basically ignore errors. You just insert into a table, and if something is already there, it doesn't actually insert. It basically automatically deduplicates. We don't have that in BigQuery, but we could use the same solution. We could just define all columns as a row identity, and then apply the same process again. Just in this case, it would be the other way around. We would just not do anything if there was already a match or insert a new record. This way, we could leverage the full parallelization of BigQuery when ingesting the data, while still maintaining a high snapshot isolation level and the full audit log and the full reconciliation capability, knowing at each exact step what we did and what happened. With that, I'm going to go back to Santa, who's going to explain how we automated that whole process inside the SQL parser.
Thank you, Jan. So BigQuery and on-prem warehouse, they are not same syntactically and semantically. So existing SQL script in current warehouse does not work as is on BigQuery. For example, delete star from a specific table works perfectly okay in most of the RDBMS system. But in BigQuery, it does not work. You need to add an additional where clause at the end. Few data type, such as small int, char, varchar, etc., there is no direct mapping in BigQuery. However, good news is, in BigQuery, you have similar data type with higher precision. Example, string and int64. So there is no data loss when you migrate the data from existing warehouse onto BigQuery. The temp table or volatile table, this construct are actually different in these two environments. So SQL parser exactly identify all these scenarios from the existing SQL script and convert them into BigQuery compliant scripts. With this script, we could improve the performance, the development effort by 50 to 60%. There are many such scenarios we have identified while going during the development phases, and we all included them into the SQL parser as and when we found it. It's a very quick tool, easy and super helpful tool. With that, let me take you to the last tool for today's discussion, that is data lineage. This tool is actually Scrum Masters and project managers' delight. What it does, it discovers the components from various layers and identify all the dependent components, starting from the ETL feed to ETL jobs, then warehouse tables and packages. So Scrum Master finds it quite useful to identify only the dependent component which is required for a specific MVP in a sprint and allocate the work. How it works? It picks up a reporting file as an input, identify the corresponding tables, from there which ETL job populate those tables, and then what is the ETL feeds required to populate those ETL jobs. A very super helpful tool. With the help of this tool, we could also eliminate the various integrations issue because the dependency across various components are actually identified right at the planning stage. Along with that, this tool also helps us for the stakeholder management. where we have a big metrics and we know whom to contact when we are migrating our specific applications. With this, I will hand it over to Jan.
Thanks again, Shanta. Yeah, so the biggest benefit for us and for me personally was really that we could work so closely together. We developed all of those tools, we gained knowledge, we could work together really on the keyboards. And yeah, we developed features, as I mentioned before, not only CMake and VPC service controls, but we worked in information schema, the merge statement, all of that hand in hand. The other benefits are going to be covered by Srini again. Thanks so much, Srini.
Thank you, Santa. Thank you, Jan. That was a great discussion. So what are the benefits of doing this? And I just want to cover that. So faster processing. So we all know that we are going to BigQuery now. And we observed that the jobs which took 1 hour or more on-prem are taking less than 10 minutes for us now. That means we are meeting and exceeding SLAs. The unified data consumption layer, because as Santa said, we are maintaining now a single copy of data on BigQuery, creating authorized views for each consumer. That ensures a parallel onboarding for consuming applications. That helps us to even federate our development and testing. And the flexible capacity as flexible scalable capacity. As we know, BigQuery is scalable and elastic, and this providing the users with the great benefits of pay as you consume. So simplified warehouse platform. So we are actually ending up with a much simplified warehouse platform, as we talked about the move and improve approach and the rationalization of applications we talked about before, as well as our the way we are simplifying our ETL jobs as we migrate. So in summary, we have taken this journey of migrating our UK data warehouse to BigQuery or GCP, and we used our move and improve approach for migration, collaborated with Google, and embraced open source. And automation has been our main focus, and we have taken the automation to next level by building many accelerators. And potentially, we are working with Google to open source these accelerators. Thank you.
All right, so I hope everybody heard that last part, right? Because as migrations is one of the PM responsibilities that I maintain on the BigQuery team. And as I go to talk to customers about things that are keeping them up at night or making them worried about doing a migration, reconciliation and code migration are very much at the top of the list. And so the last point that Srini meant is like the possibility that HSBC will be able to open source these tools, I think is really, is going to be really impactful change. So hang on, we'll get to that in a little bit. I wanted to invite you all also to ask questions. We've got about 5 minutes left here, but I wanted to leave kind of with this high-level thought. We've worked incredibly closely together over the last 3 years to get HSBC into the spot that they're in now, and we really wanted to motivate to you all that, like, as you know, Google is really good at making new technology happen, and customers are really good at guiding us into saying, hey, we need technology to solve this problem. No, not that thing over there because that's too bright and shiny, Google. We need you to solve this over here. And that level of collaboration and partnership has been really, really valuable for both Google and for our customers. And so I wanted to make that point here, and hopefully you've seen evidence of that through the story that the gentlemen here have relayed.